All right, we're going to start our next lab. This is lab number 8. This one is double shear test of threaded fasteners. Got the cameras moved around over to our Series 1100 UTM. It's a tensile testing machine, universal tested tensing machine. This one's Applied Test Systems. We just got this about 1.5 years ago, so fairly new machine, capable of 20,000 pounds. So I just did a sample test on one of the grade 8 bolts there, and I'm just going to go ahead and reset everything for now. Reset our peak, reset our brake. I've got my it set up. The fixture we're going to use what's called a double shear fixture. So I have the fixture right here, and we're going to simply lay our fasteners. In this case, we're doing, oops, if I don't hit the emergency stop here, we're simply going to lay our fasteners in here like that, and we're going to create a shear point on this side and a shear point on that side. And so this is a double shear fixture. We'll simply compensate for that by taking and doing twice the cross-sectional area. Okay, we'll talk more. I'll do a little bit of an introduction video later on. Right now I'm just going to go ahead and test these on this machine so we can get the test data, and then there'll be an introduction video that talks about double shear, cross-sectional area, and so forth. Okay, here, since I got to finish these up before Wednesday, we're going to go ahead and just do the tests, and then I'll do the other video over at my shop later next week and post that. All right, so we're going to test, first one we're going to test carriage bolts. Okay, so that's our test one. So sample 1 is a grade 1-2 or a grade A307 carriage bolt. And we'll talk more about grade, what that means. But if we look at the head of this bolt, not sure how well that's showing up. It's hard for me to see my camera and my laptop. But this one actually says 307A on it. Okay. Otherwise, we could look at something like this, where it only has the manufacturer marking on the head. There's actually nothing stamped on it. Okay. So if we look at the standard, it says if there's nothing marked on there, it's a grade 1-2 bolt, or if it's a ASTM standard, it says that if it's a A307, it may not have anything marked on it either, or it may have A307. Most of all the ASTM standards now are almost marked A307 or 307A, so that you can tell the difference between those and the ANSI standard, okay, or the SAE standard. Okay. All right, so we're going to go ahead and proceed. First one we're going to test is we're going to test a couple of grade A307 carriage bolts. So I'm going to stick them in here like this. We've got the machine zeroed, and we're simply going to hit start test. Okay, it's going to come down. We're going to use a crosshead speed of 1 inch a minute, which you can see at the bottom there. I don't really have that highlighted very much, but you can see in the bottom of the screen, it's set at 1 inch a minute. It's going to go down until it detects a break, and in this case, we got 3,532 pounds of load in order to shear that fastener. Okay, so what you guys are going to do is you're going to calculate the diameter for all of these is 1/4 inch. The peak load at ruptures, what's shown on the screen there. Shear strength, we can calculate that based on the formula that's in the lab there. It's actually load at rupture and then divided by 2 times the cross-sectional area of the bolt. Okay. Notice that we're doing the shear through the threads. So we got to make sure we use the area that would be through a 1/4 inch 20, in case these are 20 threads per inch, Unified National Course. And so in this case, the area for one cross-sectional area would be 0.0318. We would multiply that by 2, and we'd take this load at rupture and divide that by that number. Okay, and that would give us our shear strength in PSI. Listed tensile strength, we're going to get that from the chart. Okay, So the listed tensile chart, if I went over and got it from my chart here for a grade 1-2 bolt, it says that we're going to have a listed tensile strength of 60 KSI for 1/4 inch through 1.5 inch, or if we're grade 2, 1/4 inch through 3/4, we would have 74. Okay. Material-wise, this is low or medium carbon steel. Okay. Again, we're going to do a couple of them. You guys are going to take the average, use this data for your lab. So I'm going to hit return crosshead. I'm going to come over here and I'll use a hammer to, sometimes these get wedged in this fixture. I use a hammer to get it out. Come over here with a new fastener, lay it in there, just like this. And then we're going to hit start and we're going to get another number. I got a reset break, reset peak, hit start. And we're going to get our second fastener here. You guys are going to take the average, and then that's what you'll use for your numbers. Okay, 3271. So pretty close to what we got for the first one. Okay, hit return crosshead. That'll allow me to take the sample out. All right. The next one we're going to do is we're going to do 2 of the sample number 2 is going to be. Put the lab back over here. It's going to be sample number 2 is just going to be some hex head bolts. Okay, so these are some hex head bolts like this. Again, 1/4 20 still, 1/4 inch diameter, 20 threads per inch. We're simply going to lay them in there, and we're going to do a couple of these. Okay, sometimes the head markings. Again, the head marking would have no markings other than the manufacturing marking that's on this particular one. Again, not sure how well that's showing up, but hopefully you can see it. We're going to hit reset break, we're going to hit reset peak, and we're going to hit start. Again, we'll do a couple of each one, and then you guys can take the average, write down the numbers off the screen there, and you can average them to fill out the lab. All right, we got 3582. I'm going to hit return crosshead. Allow me to pull this out, and then here's the fixture I just simply used to tap those out of there. We can see that we are getting a double shear there. It did shear at 2 different planes or twice the cross-sectional area of that bolt. Okay. Again, that's going to allow, anytime I do a double shear connection, it's going to allow that bolt to hold twice the force that a single connection would hold, or a single shear. Okay. All right, we'll do another one. So put it in there, line it up, put it right there. We're going to reset break, reset peak, hit start. Okay, a little bit of variation. Okay, the other one was only about 35. This one's 3829. We're going to return crosshead. Use a little fixture, tap those out of there. Okay, again, kind of give you an idea that did a double shear on it. Okay, all right. The next one we're going to do, or sample number 3, okay, is we're going to go do a grade 5 bolt. Okay, grade 5 or an A325. Grade 5 would be the SAE or ANSI standard. The A325 would be the ASTM standard. So if we come over to the data for grade 5, we're going to get that we're going to use medium carbon steel that's been quenched and tempered. Okay, and it should have 3 marks on the head. Okay. I'll come grab a couple out of the bin here, and if we look at the head there, we can literally see that there's 3 tick marks on there, plus it has the manufacturer's symbol stamped on there. There's 3 tick marks on there. We always add 2 to the numbered tick marks, and that tells us the grade of the bolt. So these are a grade 5 bolt. Again, it's been medium carbon steel. It's been quenched and tempered, just like when we did in the heat treat lab. We heat treated them, we quenched them, and then I tempered the sample, and you guys are able to test it in the vise. All right, these 1/4 inch through 1 inch says they're going to be 120 KSI. So double the tensile strength of our grade 1-2 bolt. Well, does that mean it's going to have double the shear strength? No, not typically. Typically, the harder the material, the 80% rule doesn't really apply. Typically, grade 1-2, we can take the tensile strength and we can take 80% of that, and that would be pretty close to the shear strength. Okay. Once we start getting harder, grade 8, grade 5, grade 8, or our Allen head cap screws, that type of thing, and that formula doesn't work as well, doesn't apply as well. Okay. All right, so we're going to go ahead and make sure we're through the threads here, and we're going to hit reset, break, reset, peak, and start. Okay. So you can see we got about 6190, so not quite double. Remember, for our grade 5, we got anywhere between 32 and 35. So we should have got closer to about 7,000 if we were going to be double the shear strength. Okay, so not quite double. Okay, we're going to return the crosshead. Again, we're going to do 2 of these. You guys are going to take the average and use those numbers in the lab. Okay, I'll take another one. Just double check, make sure I had the right bolt in the box there. Sometimes these get put back in the wrong place, usually when I pass them around in lab. So we're going to hit reset, reset peak. We're going to hit start. Okay. I know this is not as exciting as some of the other labs where things go crunch and they shoot and explode. Okay, we're going to return crosshead. Again, 5196 for this one. Again, you can see that it is doing a double shear. I don't know how well it shows up on this webcam, but a little bit shinier. It'll definitely take a little more effort, a little more work hardening occurring when we're shearing those. Okay. All right. The next one we're going to do, sample number 3, is going to be or sample number 4, I mean, is going to be a grade 8 bolt. Okay. Do a grade number 8 bolt. Okay, for sample number 4. So grade number 8, if we come over to the data for that, grade 8, I could actually show you here on the sheet. I don't know how well you can see that, but grade 8 is 150 KSI, and it's medium carbon alloyed steel that's been quenched and tempered. Okay, remember, the reason we alloy steels, or we create alloys, is to improve the property, improve one property or another. For stainless steels, we add chromium to them. It improves the weatherability and so forth. Okay, so let me grab a couple grade 8 bolts. So I'll grab a couple grade 8s. We're going to look at the end of them here. Again, I don't know how well you can see that, how steady I'm holding it, but there should be 6 tick marks on the end, and it's a grade 8 bolt. Now, notice it happens to be kind of a goldish bronze color. That just the fact that these are just simply cadmium plated instead of galvanized, or instead of being zinc coated or galvanized. Okay, these have a cadmium plating on them. Only reason they have a cadmium plating, only reason I bought these is I was out and these are the only box that Ace had on the shelf there. Happened to be cadmium plated. Okay, so we're going to stick that in there. Again, 150 KSI. So if we did the calculation, 80% of that would only be like 120 is what we would expect to see for the shear strength. Okay. Again, we're not going to do the calculations here on camera, but you guys are going to take an average of the 2 numbers, and then you're going to do the calculations before you turn the lab in. All right, so we're going to hit start. All right, 5616 for the first one. Return crosshead. Again, just kind of show you a close-up. Usually I pass these around so you guys can take a good look at them. But since we're doing all this social distancing or lab distancing or whatever you want to call this, A little hard to do that. We'll hit start. And that one sounded a little harder, and it was a little harder. It went up a little higher. Return crosshead. And again, you're going to find the variations when you go to buy these bolts. There'll be some variation depending on the manufacturer and so forth. Okay. Again, one was a long one was a short one, and we can see there was a little bit of difference, even though they both say grade 6 on the end. Okay. So that's why we're going to take an average of these to do them. Now, realistically, we talked about in lab, we would take a minimum of 10 and preferably 100 of each to get good numbers. Well, that's very time consuming. Okay, so we're not going to do that in this lab, but that's normally what you do. Okay. Next sample we're going to do sample number 5. Sample number 5 is our type and grade is going to be F593SS. SS stands for stainless steel. Okay, and so we go back and look at the chart for stainless steel. It's a different chart right here. This chart right here, and I don't know if I can zoom in on that very good, but you can see that we're looking for somewhere between 100 and 150 KSI. So our stainless steel bolts actually have a range. Okay, instead of giving you a single number, they actually give you a range. Okay, so I'm going to grab a couple of those, and we're going to throw the first one in here, stainless steel. And if we look at the head, I forgot to do that, we'll look at the head on here. And again, I can't see my camera or my laptop very from here, but hopefully that's coming in. Kind of move it around, hopefully someplace it will focus. And so hopefully on that you can see that it said F593C. Okay, and if we look on our sheet, or if you look in the lab that's online there, you can see that it literally says F593C there. 1/4 inch to 5/8, 100 to 150. Okay, so let's go ahead and reset brake, hit reset our peak, and hit start. Again, we'll do a couple of them. You guys will take the average, use that for the lab. Okay, 5647. We're going to hit return crosshead. Drop it out of there. And stainless. Now, usually stainless are nice and shiny. They're pretty shiny when you shear them. There's not like a coating on the outside like there was on our galvanized or our cadmium plated ones. And so they're usually pretty shiny on the shear all the way through. All right, we'll drop this in. Again, we're doing all of these through the thread right now. We've not done any through the body. We'll talk about through the body here in a minute. So reset brake, reset peak, hit start. All right, 6595. Hit return crosshead. Sometimes they wedge, sometimes they don't. All right, so again, I'll show you the sample. Not that I think you can really see very well, but again, we're getting a nice double shear there. All right. All right, our next sample we're going to do is our sample number 6, is we're going to do an Allen head cap screw. Now, Allen head cap screws fall in their own category. I don't have a table to show you, but the listed tensile strength of this fastener happens to be 180 KSI. Okay. Now, this particular one, we're going to do 2 things on it. We're going to do a test through the threads. Go ahead and grab a couple. We're going to do a test through the threads, right through the threads, and then we're going to do a test through the body. Okay. Which one do you think is going to hold more load? Okay, well, let's do the test through the threads first of all. So let's put it in here, and we're going to go right here. We're going to go through those threads, and we're going to see what we get. So I'm going to reset the peak, I'm going to reset the peak, reset the brake, hit start. Again, this is our Allen head cap screw. Okay. So 65, 65. Turn crosshead. Okay. So you can see where it kind of sheared through there. And now we're going to do through the body. So the reason I got these long screws like this is so I could do through the body and through the thread on the same screw. Okay. Now, what do you think? Is it going to hold more load or less load through the body? Well, it's got more cross-sectional area, so it's going to hold more load. Okay. How much more load? Well, let's find out. Now, that was exciting, right? Wherever it shot the samples. Okay, well, let's do another one. So it held 10,831. Well, that's a significant increase compared to our 65 something. Okay, so typically we want to design our connections so that the threads typically hold the connection together, but the shear is occurring at the body. Okay. So again, we're going to go ahead and do through the threads, and then we'll do through the body. Okay, so we'll do through the threads. Again, this is a 1/4-20 fastener, so you can use the cross-sectional area for 1/4-20 fastener to calculate that shear strength. Okay. So pretty close to the other one. The other one we got 65, this one we got 64. So pretty consistent. Okay. And now we're going to do through the body again. Okay. Again, when you go to do the calculations for the through the body shear strength, make sure you use the right cross-sectional area. You got to use a 1/4 inch, take half of it, the radius, square it, times pi, and then double it again because it's a double shear. Maybe if I turn that, I don't know if I turn that, if that's a better angle. But anyway, we're going to hit start. We're going to see what happens. All right. Okay. So these ones actually have the end. You can see where it's nice and crystallized on the end. Definitely pretty hard material. Okay. 180 KSI. Okay. Again, more material through the body than through the threads. All right, so those are our samples that we broke. Toss them in there. All right, now our last one we're going to do is we're going to do different thread pitch. Okay, so we're going to test some 1/4-20s and some 1/4-28s. So we're going to test both of them through the threads, and we're going to see which one is going to hold more load. Okay, so I have some fine thread. I have some really fine thread, 1/4-28 right here. And then I have the typical coarse thread that we've been using. Okay. In the lab, I actually gave you at the beginning of the lab where we start talking about the lab here, I actually show you the cross-sectional area for coarse thread, 1/4-20, and then I show you a cross-sectional area for 1/4-28. Well, which one has more cross-sectional area? Well, the 1/4-28 has more cross-sectional area because the fine thread, the threads aren't as deep. They don't have as deep of valleys, and so there's actually more material there. So we would expect that a 1/4-28 would hold more load if we tried to shear it through the threads than a 1/4-20. Okay. Well, let's see if that's true. We're going to start with our, let's see. Well, if I'm on the right page, it would help. All right, we're going to start with our, let's do our fine thread first. Okay, only because it's listed on the sheet first. So go ahead and do fine thread, get it centered on there. So we're only going through the thread. Hit reset brake. Here you were at set 0. Hit start. we got about 6417. Okay. Return the crosshead. All right, so again, that's our fine thread, our first one. Okay, we'll do another one. So, reset, reset, start. All right, 5980. Okay, so return crosshead. And, oh, that one came out. Again, fine thread, kind of move it around, show you. All right, let's do our coarse thread. Okay, see where we come out. Again, there's going to be a little variation depending on manufacturer, so forth, exact formula. We'll see what happens. Okay, 5116. So that one was lower than the fine thread that we got. Okay. Again, it should be because the threads are a little deeper than the fine thread. So there's less physical material in the cross section. Okay. All right, do the second one, reset break, reset peak, hit start. All right, 5045, again, pretty close to each other, again, both lower than our fine threads, okay? So our fine threads definitely held more load, but again, when we're designing our fixtures or designing our connections, we want to really make sure that the body is what we're trying to shear. Well, not always can we do that, so a fine thread would give us more tightening capacity with the same torque on the bolt nut, but it would also give us more shear capacity. All right, so that's all the samples. That should give you all the numbers you need to do the lab, to do the calculations for the lab. Again, might do a short intro video kind of explaining the different SAE standards and the ASTM, or the STM standards for bolts. Okay, that's it for Lab 8 today.